Okay, so let's talk about the promise of async. We talked about promises. We talked about how they were a nice bit of syntax, if you will, to give us a pseudo-synchronous feel on things. Um, However, um, we still we still have some issues, right? So the reminder, right? This is a slide we talked about in the last lecture. Um, these wonderful non-blocking behaviors led us to this problem of reading the code with these long nested anonymous function callback chains that were nicely referred to as callback hell, if you will. We have this issue of trying to read that code top to bottom like it's synchronous, but actually it's executing asynchronously, and then for us to find the next thing in the call chain, we're looking back through these embedded callbacks. Makes it very difficult to read and go back up. But at any point in time, even though it feels like we're doing things in parallel, we still really only doing one thing at a time in logically concurrent multiple call chains. So you have this weird feeling of parallelism going on that makes it very difficult to think about how to debug what's going on where. And that's because it's non-deterministic, right? When something's going to finish is not very well defined. I'm going to reset to the ink annotations that we had in the previous slide so you have an idea, and I can walk you through with this diagram again how that works as a refresher. Right, so we go down. This is a logical thread, right? Each one of these HP requests, if call that slide, is handled by a sequence of things right, in the vertical dimension, but in the horizontal dimension at one point in time, we're only executing across one of those because of our single threaded model. Okay, so getting our minds around that is always quite difficult. It gives us this feeling of parallelism, but we're not truly parallel, right? At any given point in time, there's only one thing on here that's executing. Um, the Clean that up a little bit, right? At any one point in time, as we look across this diagram, right? This is time in this dimension. As I said, looking across, there's only one thing executing in time, right? We're single processor type of thing. But logically, we have all 10 of these things going on at different stages of computation. And again, we've talked about the event loop and the fact that feeding these things through the event loop in that order is going to indicate which one's being executed at one point in time. So it gives us a feeling of parallelism, but it's really more this logical concurrency. The multiple call chains, 10 call chains in this case, executing over the same period of time. Okay, but that is non-deterministic. How these 10 requests, and again, this is a diagram showing HP requests, but any kind of multiple processing going on in that single thread. All right, doesn't have to be HP based, as we know it can be I/O based with our asynchronous file I/O kind of stuff. In any event, all that's going to give us this non-deterministic feeling because we can't be assured of what's going to finish first or next or whatever else. Okay, so that's essentially our problem. We still have it. We talked about the use of promises, right? So we talked about this promise being the promise of an eventual result of an asynchronous operation. It gave us that somewhat more synchronous feeling. It preserved asynchronicity. Remember, we talked about how a promise doesn't block, but it returns that promise of future computation so that we can then say, okay, once that's done, then this is done, right? That's the feeling we kind of lose with asynchronicity is, once, let's say, let's stick with the one in the end. So once this one's done, then this is the next thing that happens, right? But the way we do it in callback land, we wind up with that, callback structure that we talked about in order to do this chaining across one logically concurrent call sequence. Whereas we're used to doing call sequences just by writing the lines of code one after the other and reading the lines of code one after the other. But again, this callback hell, as we call it, really makes it a bizarre thing to try and read and trace through and get your mind around. You can stare at it for hours, right? We've all been there. So in any event, the promise kind of helps us with that with the then blocks, but and it gets us most of the way there. Promises are really the underlying mechanism, but can we do better? Well, async await is a way to kind of take this concept further, if you will. It's really using promises underneath the hood, but it's still trying to resolve this synchronous reading of asynchronous code. So here's an example, and this code is all out there on GitHub. And I took this example from a really good internet article that is listed here, and I'll post the example for. But what's going on here? Now, this is an artificial, it's a contrived example, but basically you can introduce your own asynchronous functions by using set timeout. All right. That actually, you could even set timeout to 0. Here it's to 2 seconds, 2000 milliseconds. But if you set timeout to 0, you can actually create your own asynchronous behaviors, because that timeout will block and put things back on the event loop, and effectively add that asynchronous behavior. But here, all we're doing is taking the input parameter, resolving it to 2 times x, returning a promise after 2 seconds. All right. So then if I want to call that promise, and let's say I wanted to take, what this is trying to do is invoke this double after 2 section function 3 times, 10, 20, and 30, and then the result. So basically, this is saying take the initial starting point 10 and add it to 2 times 10 plus 2 times 20 plus 2 times 30, right? And we should get an answer of 130. But for us to sequence that, for us to make this call, then this call, then this call, we actually have to have this mini callback hell going on again, because I can't do the straight then that we saw in promises, meaning the then chaining. Here we've got to do one then the other, because each one of these is an independent call, not based on the previous one. So we kind of wind up with this mini callback hell again. I mean, even if I did directly chain them, we still have this nested callback, right? The real problem with promises is I still have this kind of thing going on right here, this nested callback business going on. In fact, that's not even the end of the scope of it, right? Really, it goes from here and encompasses the other one. So, I'm still kind of doing this mini callback hell, trying reading these callbacks to find out that are nested and anonymous, embedded within the code, to try and understand what's going on. This runs successfully, though. This all works. But what can we do it a better way than the promise way? Well, that's what async await gives us. The syntax for async await: you have to indicate a function is async in its declaration line. So when I declare a function, I have to use the async keyword in front of it. Once I use the async keyword, then within that function, I can put await as a keyword in front of anything that's returning a promise. So when I invoke a function returning a promise, I can await on the result. Basically, that's shown down here. It's the same code. All right, we're still using this top function up here, double after 2 seconds. It returns that promise. But now I can await on the call to 10, await on the call to 20, await on the call to 30, because I put the async here. So we added an add async function. We labeled it as async. We put an await in front of each one of the 3 calls, and then I can go ahead with this computation. This reads, far more sequentially and synchronously, like we're used to reading. I mean, this is starting to resemble code that you write in a traditional non-asynchronous language. The important thing to realize between this and blocking code is that this await does not block. Yes, it's waiting for the result of this to do this, but it's not blocking. All right. So basically, back to here, when you call await on something, if the computation here depends on something that happens here, or for whatever reason you want it sequenced after, and you want to ensure that, then instead of using a callback, which is the way we were doing it traditionally, that's the mechanism. Now we can use await, so we can write the lines of code 1, 2, 3 like that, instead of writing them as this callback, nested callback business. All right, so the await will say, don't start this until this one completes. But this still has to wait its turn in the event loop. It does not block all the stuff that happens in between here and here in these other requests, these other logically concurrent execution sequences, if you will, call chains, I guess I called them here. Those things all continue to go on. All right, nothing blocks. The thread does not sit there and wait. That's what's different. If I made double after 2 seconds a blocking call. Now again, this is a contrived example, but assuming double after 2 seconds really represented some long-running computation, right? One of these guys, again, if I block in that, nobody gets to execute, right? If I block and wait, nobody gets to use the event thread. Nobody's doing anything, and that's the problem. So we want to maintain that asynchronous event loop is still running, the hamster's still running on the treadmill, while giving a synchronous reading and recovering a more cognitively pleasing, if you will, reading of our synchronous call chain. All right, so this is synchronous reading code. All right, a synchronous reading sequence that has truly asynchronous behavior. Okay, that is the power of what async gives us. Really improves the readability of the code. So let's go look at that example in our editor a little bit more. And basically what I have here are 3 different versions of the double after 2 seconds. I did take them from that article, as I mentioned. The first one up here, well, think about straightforward. If we're trying to take 3 of these, 3 calls to double after 2 seconds and add them together, this first way won't work. Well, why won't it work? Well, again, set timeout gives me an asynchronous behavior, right? I'm setting a timeout and saying the computation will be done 2 seconds in the future, but the timeout drops through, which means double after 2 seconds drops through. It goes on, so while you're doing double after 2 seconds 10, you're moving on and doing double after 2 seconds 20. That's another call. And similarly, double after 2 seconds 30, and then I get to the console.log. The console.log does not block, right? All these are asynchronous, so they drop through, and that's going to be executed immediately. The problem is since I'm artificially introducing a 2-second wait, when I get down to this console.log, val1, val2, and val3 are not going to be bound. So if I go over here and run double after 2 seconds.js, I got NAN, not a number, right? Because I'm trying to add 4 things together, 3 of which are not bound to a number yet. Okay, so that's why the first example will not work. All right, so a promises version is what we saw in the next slide, right? We return a promise. We do the mini callback hell, as you say here, with the nested callbacks embedded inside. And then here's a couple calls, one to add promise of 10 and one with add promise of 15. Notice that async functions by definition also return a promise. Okay, so up here, when we do add promise, we are returning a promise as it, I'm sorry, I'm not in async. That's why I messed myself up. I'm returning a new promise here to start with in order to call the then down here and wait for the result. Okay, so I have a promise function calling another promise function. I got ahead of myself there. So if I call this one, which was double promise, all right, this one's going to wait. Now things are waiting. No console.log, right? And actually, notice how there's 2 outputs going on, one after the other, and I got 2 different results of 130 and 135. Well, why is that? Well, again, if you look back here, I'm calling add promise with 10 and add promise with 15. Remember, promises resolve right away as soon as they're declared defined. Meaning, the first add promise call does not complete. Even with that mini callback chain, it doesn't complete. It executes add promise with the first 10, goes and starts that sequence, and immediately drops down, because we're asynchronous, remember, to the next add promise of 15. That's why you see the 10 here, the 15 here, the 10 here, the 15, the 10, the 15. All right, those are each happening. That's true concurrency in that call chain. In fact, if you looked at what the output is basically telling us is, let me bring up my little sketch pad here. What really happened with this call chain, should have had that up already, is with the add of 10, and then we had the add of 15. If I look at this like the diagram back in the note showing those 10 requests, I would have the first call of to double with the parameter of 10, right? This is the call to double after 2 seconds, right? This one add 15. Also, they're each using a 10, 20, and 30 sequence, right? But in terms of looking across time, the first one happened with the add of 10, and then the Next one happened with the 15. That was the second console.log. Then this one happened over here with 20. And then this one happened with 20. And this one happened with 30. And then this one happened in 30. That was the order of processing, even though I have these logical 10, 20, 30 here and the logical, I'm sorry, this is 10, 20, 30 here with the two different initial parameters. So the end result here was 10 plus 2 times 10 plus 2 times 20 plus 2 times 30 equals 130. This is still the same part here, except for it's plus 15, so I get 135. Okay, that's what, but the real thing isn't, the computation again is a contrived example. That's not what's important. What's important is you can clearly see by the console log.outputs that the two logical concurrent call chain sequences are interleaved, meaning that I did have true asynchronous behavior that I've dropped down using my promises. So, that all works well and good, well and great. But again, our biggest problem is right there, our mini callback hell. So down here at the bottom, and again, all this code's in GitHub. I'm going to make this bigger now. Now we can do and I want you to focus right here on this part at the top. I'm not going to worry about the add async parallel yet. We'll get to that in a minute. The add async now does an async, right? Async, oops, an async with the corresponding awaits on each one of those calls. So even when I make the same two calls here, and notice I'm still using the same calls, I'm still using a then, because by definition, even though I have a return statement here, which makes you think you'd return some kind of int or something, this is always going to return a promise. So effectively, this is more like resolve returning that int some value, all right? Which means I still got to call a then on it down here. In fact, I have these two common outlines, but I'm going to come back to that in 1 second. If I run this version, all right, and I do node of double async.js, actually, I'm going to do something real quick, just to try and make things clear. I'm going to comment out this here so this doesn't print out. I'm going to go over that in a minute, so we'll come back to this. So if I go here and I run double async, right? Same kind of thing. They're still interleaved. They're still happening every 2 seconds. I still get the same value. So really, I mean, it executed the same way. And again, it executed the same way because it is the same way. There are promises running underneath, even with async. Async is a syntactic sugar over promises that, again, lets me write code that looks synchronous, like, sorry, I'm looking at the wrong one. Code that's synchronous that looks like this right here. That's the code we just executed. Okay, so absolutely having a hard time with the pen today. So now we executed these three things. Now think about how this really worked, though. All right, how this worked is I did an await, did double after 2 seconds, computed that, waited 2 seconds. You saw that on the screen with both of these. Now, addition's commutative, right? To get the result of 130 or 135, I didn't have to perform those 3 add operations in sequence. I could have performed them in any way I wanted. Okay, so that gets us to our next trick, which is nice, which means you can use await with promise.all. Now in the promise lecture, I didn't talk an awful lot about promise.all, but I did mention that promise.all takes an iterable and returns a promise that resolves when all the promises in the iterable have resolved, or rejects when the first promise rejects. Here we don't really have a jack, we're just adding numbers away together. But I can take and call a promise.all, meaning I can invoke each one of these that returns a promise, right? And I can invoke those things independently and bind them to the corresponding return values, and then do the sum after this block ends. And I can await on the whole thing, which means basically I'm not going to drop down out of the promise.all. I'm going to wait for all of this promise to get resolved, so then I can do the sum. So this is slightly different. Okay? In the first one, we were saying, let's call, actually I already have it drawn over here. And this one, and this was the promise one, but this is the same thing happening as async. Remember, async was just syntactic sugar. we were doing the add after 2 seconds of 10, then doing 20, then doing 30. We sequenced them with the then, all right, is the point. What we're saying is there isn't anything about doing an add, a double add after 2 seconds that relies on this one being done first. So I don't have to care about the order, which means I can actually make these things go independently in their own logical call sequence, as long as I can await for when all three are done, so that then I can do this, right? So I've drawn dashed lines over to what, this is a cheesy version of an activity diagram, if you remember those. You should. That had, if you remember, that we had these parallel bars called fork join bars. Right? Now we got to be careful. We are not truly parallel. We are not truly, multi-threaded or multi-process. We are single-threaded. So there's still only one thing executing at a time. But now we're basically logically independent across these, right? We're not sequencing one after the other to get to the end. We're saying each one of these can run concurrently as their own logical sequence and come down at the end. So really what we're talking about is the diagram for this one. Over in this example, instead of looking sequential like this, would actually look like, so we're doing add async. This is the parallel version. What we really have starting here is we have the one doing 10, the one doing 20, and the one doing 30, and all those are going to complete, and then I can go and do the sum. All right. Now again, these are not truly parallel, so the semantics of a UML activity diagram aren't really appropriate here. But the point is that these things are logically going on concurrently. And it's non-deterministic which one gets done first. I don't care which one gets done first, as long as I wait for all three of them to get done so I can complete my sum. All right. So if you have independent tasks like that, then you can use promise.all combined with await, and you actually wind up getting something that's much more performant. So let me go back to that's the bottom part in this editor. That's what this code I was skipping over does. Notice here was the await with the promise.all. There are the three calls. I'm not awaiting on each individual one, so that's how I go from sequence to being this pseudo parallelism, if you will. So I'm going to take and now comment this back out, or comment it back in. I'm going to take, actually I'm going to leave that one in there because you're going to see something interesting when I run this. All right, so I'm running both the sequential version with async await, and I'm also running the pseudo parallel version. All right, I'm going to wait 2 seconds. Now notice the 140, 145 came out first, and it came out right after the first two printouts, the first two calls. Why did that happen? Well, what really happened is I was running, now basically what I just ran was all of this together at once, right? So basically this part slotted itself in right here after this call and this call, and happened immediately because they were all happening in this pseudo parallel version. That's why I got, even though I made the calls in the code after the calls to the sequential version, this one got done first. All right, 140, 145, that's because I called these with 20 and 25, which means this is the one that got 140 and this is the one got 145. That's after these, but the output came out first. Why? Because again, I run this one, I run this one, I run this one. These all drop down. They're all asynchronous, and these are going to go sequentially, right? Which means I did the first await on 10 on each one of these two. That's what the first thing that was. That's why I got the printout with the console.log first. And then this one went and did the promise.all on one spin around with the await on all of the 10, 20, 30 that we saw. And I did that for the one with 20 here and the one with 25. It'll be the same thing over here. All right. And that's why it came out in this order, and then I returned and still had to complete, right? That's that body of work. And then I still have to complete these by calling the one with 20 and then 30. All right. So again, I know I'm talking fast through this, but I think you should really look at this example in some detail and run it yourself and mess around with some of the orderings to get a feeling for how did that exactly happen? Why did that exactly happen that way? The last thing I want to notice with this particular example, and I mean, I think this is, even for me, is a messy video. But notice how I commented out the first one, right? So I commented this out up here of calling the add async directly or calling the add async parallel. What do you think will happen now that I'm gonna do all these? Well, these are still going to execute first, but they're going to execute again asynchronously. But what is console log actually going to print out? Notice how it comes back right away and both of them output promises, and then we see the same kind of stuff we had before. Why is that? Again, when you make this call, a promise does return immediately. It does resolve immediately. So, and each of these, remember, are going to return a promise. Right? When I go up to add async, even though I don't have a return of a promise, like I said before, I'm not returning this value right away. I'm not returning this value away in either one of these. These are asyncs. Asyncs are going to return a promise object. But again, the promise is not going to resolve until everything's done, either sequentially or in parallel, which is why after that initial printout here, right, after the initial first two printouts, which happen right away, 2 seconds, and then we go through the sequence that we talked about over there. Okay, so we got all kinds of interesting stuff and interesting behaviors going on with the async await. Async summary remembers the promises can start to get us out of callback hell, but we still had the mini callback hell to deal with. So async gives us that even more synchronous field asynchronous code. It gets rid of the mini callback hell. You still have promises underneath though, right? We just showed that with the calls we just made. So you can, and that's a benefit. We can still do neat things like await on promise.all like I just showed you. The cons still remain. We still have a little bit of performance hit. There's still promises underneath, so we still have a little bit of overhead. And it's still intrusive, right? We had to go in and mark a function as async, and we had to mark a statement as await. So there's no transparency to this. You have to go throughout your code and determine what functions need to be marked async and what places do you want to take an asynchronous function returning a promise and wait on it, basically. All right. ECMAScript 2017 or ES8 is what added built-in support for async. Before that, it was like promises in ES6 or third-party libraries. Node added this, I think, in version 10. I think it just appeared in version 10. Before that, you had to use this thing called a transpower. I'm not going over transpowers in this course. They are part of an ECMA standard, just like promises. So you'll see you can do async await in the browser now too, which is very helpful.